In this video, we're going to see how we can use Excel to do a test to see if two variables are correlated. This question says, listed below are numbers of internet users per 100 people and numbers of scientific award winners per 10 million people for different countries. Construct a scatter plot, find the value of the linear correlation coefficient, R, and find the p-value of R. Determine whether there is sufficient evidence to support the claim of linear correlation between the two variables. Use a significance level of alpha equals 0.01. So here we have some data about internet users and award winners. The first thing we're going to do is open this in Excel. We do that by clicking the little blue box in the top corner and clicking Open in Excel. So here's our data. The first thing we wanted to do was construct a scatter plot. So to construct a scatter plot, all we're going to do is highlight the two columns with the variables in it. The variable we want for the x variable on the horizontal axis is on the left, and the variable we want for the y-axis is on the right. Then we're going to go up here to Insert. And once we click Insert, we see all the different options for graphs. We're going to choose this one right here and choose the first one, Scatter. So this is the scatter plot for our graph. Notice if we click on it, there's going to be an option here to add chart element, and that's where you can find different ways to give the graph a title, to title the axes, and all kinds of things like that. In this case, we don't really need to do that because we just want to see the shape that the dots in the scatter plot are forming. So this is the shape. So if we look back to our options, it looks like this is the correct one. We can check again. We see the dots kind of start off low in this pattern like so. And if we check again with what we just created, that's the same shape of the dots in our Excel graph. So it should be letter A. Next, we want to find the linear correlation coefficient, which we denote as R. So to do that, we're going to add in some features to Excel so we can do this without too much work. If we go to the Data tab right here, you'll want to look to see if you have something called Data Analysis installed. If you don't see Data Analysis, what you want to do is go to File, Options, Add-ins, and then down here where it says Manage Excel Add-ins, click on Go. And you want these first two boxes to be checked, Analysis Toolpack and Analysis Toolpack VBA. Then click OK, and after that you should see this Data Analysis button come up. Okay, so now that we have done that, we're going to click on Data Analysis, and we're going to go down to where it says Regression, and click OK. So first it wants to know where the y variables are. The y variables were here. That was the award winners. The next thing is the x variables, so that's going to be here. So I highlighted these without highlighting the labels at the top. Therefore, I can leave this box for labels unchecked. But if I didn't do that, for example, if here I did highlight that cell at the top with the label, same thing for the X. If I did highlight that cell at the top with the label, I can just click on labels right here, and then the program will understand that it should ignore that first line because that's just giving it the title and not an actual value. You can decide to have these results put in a new worksheet if you like. I prefer to have it on the same worksheet. So if you click Output Range, that will be on the same worksheet, and then you can just click on any cell you want, and that's where the information will start to be presented. That's all we need here, so we're going to click OK. And then we notice all this information comes up. Let me move our graph over so it's not in the way. So the value we want here for the R value is going to be this one. This is the value where it says multiple R. That's the value of the correlation coefficient. So 0.806, etc. is the value of R, the correlation coefficient in this case. Let's go back to our problem and see how many decimal places we wanted. So this said to round to 3 decimal places. So if we go back, we can change this cell by going to the Home tab and clicking over here. This is to increase or decrease the number of decimal places. So we can decrease this down to 3. So 0.807 is the correlation coefficient value for this problem. 0.807. Next, we want to determine the null and alternative hypothesis. So for a test about correlation, the null hypothesis is always that rho, which is the population parameter symbol for correlation, similar to R. So R means it came from a sample, and rho, the Greek letter rho, means it came from a population. So this should always have an equal sign in it, and it should always be equal to 0. What this means in a sentence is that there is no correlation between the two variables. And the alternative is going to be that rho is not equal to 0. Rho not equal to 0 in English means there is correlation. So that's what you need to remember. In any test for correlation, the null hypothesis will be rho equals 0, and what that means is there is no correlation between the variables. H1, the alternative, will be that rho is not equal to 0, and that means that there is correlation between the variables. Next, we need the test statistic. So if we go back to Excel, we should be able to find that test statistic. So the value we need for the t-test statistic is going to be this one right here. Let's use a different color for that. So you can see this labeling here says t-stat, and this one here at the bottom, not the one on the intercept row, the one on the row that has the labeling for whatever the variable was, that's going to be your t-statistic, your t-test statistic. So let's go back to the question and see how many decimal places they wanted. We wanted to round to 2 decimal places here. So if we go back, we can go to home, and then over to this button and take this down to 2 decimal places. So 2.73 is going to be our test statistic here. Next, we need the p-value. So the p-value is right next to that number. That's going to be this one right here. You can see it says p-value. Again, we want the one that's on the row for the variable that we're talking about. And for the p-value, we wanted 3 decimal places. So we can take this to 3 decimal places, like so, 0.052. So the p-value is 0.052. And there we go. So now we need to make a decision about whether or not there is correlation in between these two variables. So remember, the way we make a decision is we compare the p-value to the alpha value, the significance level. The rule is if the p-value is smaller than the alpha value, smaller than the significance level, then we will reject H0. If the p-value is bigger than the significance level, we will fail to reject H0. So in this case, the p-value is 0.052 and the significance level was 0.01. So here the p-value is bigger than the significance level. Therefore, we should fail to reject H0. So coming down here, because the p-value of the linear correlation coefficient is greater than the significance level, there is sufficient evidence to support the claim that there is linear correlation between, there is not sufficient evidence to support the claim that there is linear correlation between internet users and scientific award winners. Why? Because again, the p-value is greater than the significance level, so we did not reject H0. Remember, H0 is what said there was no correlation. So we couldn't reject the notion that there was no correlation. So in other words, we did not find evidence that there is correlation.